So in the previous video I discussed combinations and permutations, and while that may seem a bit unrelated to the topic of binomials, today's video I will mainly focus on binomial expansion and how that's related to Pascal's triangle. You may have heard Pascal as in the unit of pressure, but it is also a very useful triangle related to binomial expansion. So first off, it's going to be really productive if you understand what a binomial is for the latter of the series, and also specifically this video in particular. So if you're understanding what a polynomial is, where you have some variable x or z or whatever you'd like in ranging powers with different coefficients, you have yourself a polynomial, and each thing being added is a term by itself. And when you have one which has two terms, and it even doesn't have to have an unknown variable such as x, it often does, but it doesn't have to, and in that case it's a binomial with the prefix bi relating to its two parts. Now you may notice that these look just like factors for quadratics, cubics, equations which you've probably solved by now, especially quadratics if you've seen my previous videos. If you're trying to solve it, the best method for quadratics is definitely factorization if you can, and these give you binomial factors which you rearrange for x. Now if you were reversing this method, you'd expand the brackets however you'd like to, and this becomes, you may notice some patterns when you have the same factor repeated, a repeated linear factor twice to give out a quadratic. You may notice that there's some pattern with the numbers produced, the terms for your quadratic. In particular, you'll notice when expanding into a quadratic, the highest power, often called a degree, in a quadratic is 2x squared, and you'll notice that there's 3 terms, and this is the same for cubics where the highest power is 3, and there's 4 terms. You'll always have one more than the highest power, the degree, terms in a polynomial. And in today's video I'm going to try and explain how Pascal's triangle can give you some useful coefficients, binomial coefficients, which help describe when expanding a bracket. So if you have 2 terms, binomial, a plus b, a can be anything and so can b, when raised to a whole integer power, we're timesing it by itself that many times. I'm going to be referring to this power arbitrarily as n if I'm not giving a specific example. And this is going to give us out a polynomial if we binomially expand it with n plus 1 terms. Now when you do this, you'll realize not only do we have terms relating both a raised to some power and b raised to some power, but also there's some other coefficients, the binomial coefficients I mentioned earlier, and a way to figure them out is drawing Pascal's triangle, where we sort of have, we start off with 1, then we write 1, 1 beneath it, and we're going to write in numbers in sort of like a brick layer, where each row is slightly offset to the side, such that every number has 2 numbers above it, unless it's to the side, which we'll notice will always have 1s to the side. You could think, and now what you can think of, the 2 numbers above each number are sort of like parent numbers, and each parent numbers have a child number beneath it, and the sum of the parent numbers will always equal the child number. This allows you to draw lower and lower rows for Pascal's triangle, and you can always write more because you can always add up the 2 numbers, and this will make bigger and bigger rows as the polynomial gets bigger. If there's numbers on a side such as the 1, you could always think of on its side being a 0 as well, just unwritten, meaning that its child's product will always be another 1, and therefore you can write out any number in Pascal's triangle. But what's so helpful about Pascal's triangle is every number in it is a binomial coefficient. The first row corresponds to the power of 0, and the second row corresponds to the power of 1. Raising any binomial to these powers, you will get these coefficients for all the terms in it. So you could generally think of the power being n corresponding to the n minus 1 row, and each term in it corresponds to the coefficient in that set term. So you read it from left to right essentially.